Hello everyone, welcome to the next session of SAP HANA online training tutorials. So in the last session, I have explained about SAP HANA Studio look and feel, what are the different perspectives we have in that, and what are the different operations you can do in each perspective. So in this session, I'm going to explain you about SAP HANA architecture. So last session, we have seen the software part of HANA. And this session we are going to see the hardware part of HANA, like how the HANA database has been built and what are the different components we have in HANA database and what is the functionality of each component. And we'll also see what are the advantages and disadvantages with row storage format as well as column storage structure. So let's get into our HANA architecture, HANA database architecture. So basically our HANA database is a combination of different server components. So if we look at this picture, we have different server components in one particular HANA database platform. So we have index server, we have preprocessor server, we have name server, we have statistics server. Along with these 4 servers, we also have another 3 more servers, which is Access Engine, and then SAP Start Services, then Daemon server. So these are the 7 different server components we have in each HANA database. So now, what is the role of each server component? So the major server component in HANA is going to be your index server. So index server actually holds your data in HANA. So it holds all the data, and index server is the one which is going to perform all the operations in HANA. So whenever you execute any data model or whenever you process anything, all the processing will happen in index server. So the different server components we have is index server, name server, preprocessor server, statistics server, Access Engine, SAP Start Services, Daemon services. So even we can see all these server components in HANA itself. Let's get into our system. And if you go to administration console, make sure you are in administration console and then double click on your system. Okay, so once you double click on your system, the first one is going to be an overview part of your HANA database. And if you go to landscape, this is where you can see all the server components you have. See, you can see different server components here. And we have missed another one, which is compile server. So these are the different server components we have. So as I explained, index server, this one holds actual data in the system and processing. So all the processing happens in index server. So we can say index server is the heart of HANA database. And then name server. So name server will work as a metadata information for your HANA. So when we say metadata information, it will have all the information about where the data has been stored in the index server and in which location the data is. So the name server will hold all the metadata information, like where for one particular table, where exactly the data is located in index server. So all those address information at memory level will be available in name server. So this will hold metadata information. Okay, and then preprocessor server. Preprocessor server is actually have the capabilities of text search information. So when we say text search information, I'll give you a good example for that. So even if you see here, it's like when you want to process unstructured data like text analytics, when you want to um, search some information from your text files or from your PDF files, if you want to do such kind of analytics, then a preprocessor server will come into picture. And the other example when the preprocessor server comes into picture is, let's say you are creating an attribute or any modeling object. Okay, so if you open any modeling object, I have find option here, search. So if let's say I want to see whether this particular SPERR column exists in this or not. Okay, so I'll just enter SPE or SP. So it highlights all the columns that starts with SP. So this is nothing but search capability, text search. So it has to read all the tables metadata, and then it has to give me the columns that are starting with SP. So this is nothing but search capability. So all this kind of processing, when you try to do some search finding things in HANA, all this will be operated in preprocessor server. Okay, now so we can say text search operations happens in preprocessor server. And the next one is statistics server. This will collect all the statistics about your HANA database, like volume information in each server component, or memory consumed by each server component, and what is the status of your HANA database, and then what are the queries that has run in the system, how much time those queries has took. All the statistics information will be collected by statistics server. It collects all the system statistics. Then comes Access Engine. So Access Engine is nothing but a web engine in HANA. So whenever you want to access data via HTTP, internet, okay, via HTTP, data access via HTTP, then your Access Engine comes into picture. Then SAP Start Services. This is nothing but it will have a component to start your SAP HANA database. So it's like start HANA DB or HANA system. Okay, and then this daemon is to make sure whenever you restart the HANA system or whenever you stop and start the system, it will make sure all the server components starts in the same order or in the required order. So that will be taken care by daemon component. So it takes care of the server components starts in proper format, and then compile server. So this compile server will come into picture when you do a validation on any modeling objects, or when you write any JavaScript and try to compile those scripts. This will come into picture. Compiling codes in HANA system. So these are the different server components we have and functionality of each server component. So if you have only a single node system, then you are going to have all these components one each other. But if you have a multi-node system, let's say you have 3 node system with 512 GB each, which is going to be a total of 1.5 TB system. In such cases, you are going to have 3 index servers, 3 name servers, 3 preprocessor servers. So all those servers information you can see in the same place. Right now, if you see a distributed system, no, which means it's a single node system. If you have a multi-node system, then here distributed system will be yes. In such cases, if you go to a landscape tab, you can see how many nodes you have based on the how many servers, how many number of servers you have. Let's say if you have 3 index servers here, which means it's a 3 node system. If you have 2 index servers, it's a 2 node system. Okay, and if you have total 1 TB here with 2 node system, which means it's 512 GB each node. So in that way you can identify whether it is single node system or multi-node system. So each node will have bunch of these servers. So how many nodes you are going to have? You are going to have those many server components here. Okay, so this is about the high level architecture about HANA database. Now, as I already explained, index server is going to be the heart of HANA system. Let's look at in detail about index server, like what are the different component objects you are going to have in index server and how each operation will be executed in index server. So if we look at index server architecture, this is how it looks. So we are going to have these many components in index server itself. So how all these components works in index server, or how a single operation will be performed in index server. So now let's put a diagram here where we have tables. Table 1, table 2, table 3, and on top of this we have got our modeling objects. It can be analytic views or calculation views or attribute views. So I'll put one analytic view, one attribute view, and then one calculation view. Now these are part of HANA. So these all part of HANA here. Now when we build reports on top of our modeling objects, let's say we have got reports here. Okay, so we have got reports on top of our modeling objects. So at the end, modeling, all these reports will get or will try to fetch data from our modeling objects, and we all know that now our modeling objects are runtime objects. So all these modeling objects doesn't store a data physically. It internally fetches data from these tables. So your analytic view can be on top of all 3 tables. Okay, and then Your attribute view may be on top of just one table. Your calculation view may be on top of two tables. So if you have a report which is built on calculation view, then whenever this report runs, it will push an SQL statement into your HANA, which tries to access your calculation view, and in turns this calculation view tries to get data from these two tables, because this calculation view has been built on table 2 and table 3. So at any point of time, whenever you execute this report, it is going to hit your base tables. So now we'll see how this operation happens in index server. So the first component we have in index server is connection and session management. Okay, so this is the first component we have, connection and session management. So let's say you have built a report called ABCD. Now user has come and he has opened the report, which means he is trying to open a session with HANA so that he can fetch the data for that particular report. So all those connections and sessions will be managed by this particular component, connections and session management. So whenever user executes a report, or whenever user tries to do certain operation on HANA database, the system will open a session. First it will open connection, and then it will open a session for that particular user. So all the connections and sessions you can see here under sessions. So all these sessions will have a status, like connection status idle or transaction status inactive or active. You are going to have all this information under performance sessions. Okay. Then the next component is authentication. Once the session is established, the first thing system will check is whether that user has proper authorization to run that particular operation in HANA. Now you're trying to access data from a calculation view. So what you're trying to do, you're trying to run a SQL statement which says select star from that calculation view. Now what this authorization component will do is it will check whether you have authorization to run select star on that particular calculation view or not. If you have authorization, then it goes to this block where the execution will happen. Okay, so in this we have different components, which is SQL processor, stored procedure processor, planning engine, MDX engine, calculation engine. So most of the SQL operations, joining tables, all those operations will happen in SQL processor. If you are running any stored procedures, those things goes to stored procedure processor. Or if you are running any planning applications on HANA, then that goes to your planning engine. Or if you are a reporting tool from where you are executing your reports is a multidimensional expression language tool like BO analysis office or BEX queries, then those operations will goes to MDX engine. Or if you are trying to access modeling objects, what are the modeling objects we have in HANA, like attribute views, analytic views, and calculation views, that goes to our calc engine part. So this actually is not a calc engine. We can say HANA engines. We have 3 different engines to process our modeling objects. I'll explain you those 3 different engines available later in this same session. So this is about execution control part. So once it identifies which engine has to process that particular operation that has been requested by user, so ultimately it has to go to your base tables. It has to access the base tables. So that is where it links to your data here. So your data might be residing in row store tables, or your data might be residing in column store tables. So it tries to fetch the data from here. And then you have a transaction manager here. So transaction manager is nothing but when you're trying to insert the data, or when you're trying to manipulate the data in the system, it will have all the information about the transactions that you're doing, or the DML operations you are performing, data manipulation operations you are performing, because it has to make sure that the commits are happening properly and the data is consistent all over the period. So all that data manipulation activities will be taken care by your transaction manager. And you also have repository component here. So repository means uh, metadata for all your objects you have created in system. So all the metadata will be under a SysBIC schema. So if you go here, you have a SysBIC schema. So you are going to have all the objects metadata information here. If you go to column views under SysBIC schema, this is where you have got all the metadata for your modeling objects. In the same way, system relevant metadata will be under sys_bi as well as sys. So these two schemas will hold system relevant metadata information, and your SysBIC holds modeling objects relevant metadata information. Okay, then comes your persistency layer. So why do we need persistence layer here? So we are all talking about SAP HANA, which is in-memory database. So in memory, it's a volatile. So you power off the system, it's gone, because RAM is a temporary data storage place. So until unless the system is on, you have everything in the RAM. But once you switch off the system, or once the power failure happens, you have nothing in the system. So that's the reason you should have a persistence layer where at any time you have the replica of your in-memory available in your persistence layer, so that whenever the power goes off and it comes back, you can quickly move back or copy the data from your persistence layer to memory, which is going to be your HANA. So this persistence layer also will be a part of HANA database itself, so that whenever you try to copy data back to memory from persistence layer, it will be very fast. Within like 20-30 minutes, you will have your entire data set available in your memory, which is copied from your persistence layer. This will be useful when you have power failures in the system, so that you don't need to go back to your source systems to pick the data again into HANA. Okay, and then the next component here is data storage or a backup purpose. So it is still fine if you have power failure, you have your persistence layer from where you can pick the data again to memory. What happens if you get a system crash where even your persistence layer will be gone? Because system crash in the sense your system is gone. So in such cases, it is always better to have external backup. So that is where you get your disk storage backup component in the bottom here, where you will be consistently taking a backup of the system. So whenever the system crash happens, after you reboot the system, you can again get the data back from your backup to system. So we'll talk about the persistence layer and database backup in our next session. So in this session, it's going to be the major components we have here, like session management, transaction management, and then different engine components we have here, like SQL processor, stored procedure processor, planning engine, MDX engine, and the row store and column store part of it. So as I explained, instead of calc engine, it should be engine components here. So we have three different engine components to process queries on HANA modeling objects that we create, like attribute views, analytic views, and calculation views. So we'll see what are those three components, three engine components we have, and how those been used when you write or when you execute any modeling object. So we have, as I explained, we have three different engine components to process the modeling objects. So those are join engine, overlap engine, and then calculation engine. So now whenever you run a query on attribute view, or whenever you run a query on base tables, so it can be your base tables or attribute view, then that particular operation will be executed by join engine. So that's the basic principle. Now, what is overlap engine? Overlap stands for online analytical processing. So if you have an analytic view and tries to run a query on top of analytic view, then overlap view comes into picture. And then the next one is calculation engine. With the name itself, we can say if you are going to run any queries on calculation views, then this comes into picture. So how can I see which engine has been called for different modeling objects in HANA? So we can see that. Now let's get into our HANA system. So let's say we have this modeling object which is AT_customer. So AT stands for attribute view and it's a customer attribute view. So now we can do a visualization plan on this, which tells you how this will be processed when you run a query and how much time it will take to give you the results. So to run a visualize plan for that, let's open an SQL console. So where I'll just try to execute select star on this. So these are package name, and then our object name is AT_customer. So I've executed this, and how much time it took? So it just took 11 milliseconds, 28 milliseconds to give me the data. Now I want to see how this is processed at the backend. So to see that, just right click on that statement and say visualize plan. Okay, just press S. Now this will take you to SAP HANA plan visualization perspective. This is another perspective. So you just click on this. Then now I'm going to execute this to see the detailed plan about it. So now I've got the detailed plan which says it has taken 23.5 milliseconds to process this in the backend. Now I want to see the details. So click on this arrow mark. So it says it has taken 18.8 milliseconds here, and to process that it took that 8.4 milliseconds. Now let's get into further details. You see here, so it is trying to access 3 base tables, and these are the number of records it is trying to access from each base table. And here if you see, it says join, so which means it is using join engine. So it has used join engine to process that, and so from each table it took like 0.8 milliseconds here, and then 0.7 milliseconds here, and then 0.8 milliseconds here. And here to join all the 3 tables and to perform whatever the joins we have created in that, it has taken 13.2 milliseconds, and the remaining is time taken at each table level. Then to assemble that results, it has taken additional 4.8 milliseconds. So this is going to be total. So here the total is 14. Here the total is 18.8. So the remaining 4.8 milliseconds it has taken to transfer data from here to here, or resulting assembling that results. And then from here to here it has taken another, how much time? Another 8.4 milliseconds. So in this way you can clearly understand how this has been processed in the backend and how much time it has taken at each level. So with this you can say it has been processed by join engine. Now in the same way, let's look at any one analytic view. Let's say I have AN COPA actuals. Okay. So let's execute this. What happens? Invalidated view. Okay, this has been activated. Let's see if there is any spelling mistake. I don't see anything. Okay, why it is not why it is not accepting this query is because our analytic views are OLAP objects. So for any OLAP object, if you want to run, you need to have a group by function available. So for that, what we'll do is, or instead we can straight away go for visualize plan. Okay, let's see the data preview of this. Okay, let's go into raw data. So it has taken 95 milliseconds. So instead of writing all the group by statement, what we can do is, once you get into raw data place, you can see the show log option here, and you can see the generated query. So you can directly copy this SQL statement. Okay, so you can copy this, close. By default, as it is showing 200 records here, in the SQL statement you are going to have condition for that 200 records which says top 200. So you remove that and then execute this query. So now it will get execute. So now select this, right click, visualize plan. Now this will give us visualization plan. So these our part. Now let's execute this. So now we have got in detail plan. So it has taken 86.7 milliseconds in total, and the below processing has taken 50 milliseconds, and the data transfer has taken 36 milliseconds. Now let's get into details. Analytical search. Okay, let me maximize this, and I'm going to decrease this zoom percentage. Okay, so here if you see BW pop expression parsing, BW pop aggregation. So this is nothing but your OLAP engine. So for OLAP engine you are going to get a description like this. Okay, and internally, as we have attribute views inside analytic view, it internally calls join engine, but the major operation will be performed with the help of OLAP engine. So that's how you can identify which engine has been called when you execute any modeling object. Now to give you one more example about engine components, let's open this attribute view we have, and let's create one calculated column here. We don't have any calculated columns right now, so let's create one calculated column which says test. I'll just put test column, and then I'll assign integer as data type. So I'll just select as it is one column, let's say KUNNR, and then validate the syntax, then execute. Is executed successfully. Now I'm going to run visualize plan on the same attribute view. Copa scenario 80 customer. Okay, so we have got data preview for that. Let's execute visualize plan, then get into the details, right click, execute. Okay, so now we have got in details here. Okay, let's project plan join engine. Let's see the result assembly here. Requested attributes. Usually when you have any calculated columns created in attribute view, along with join engine, it will also calls a calculation engine. Probably we have not kept any function for the calculated column. So let's open this. Let's open the test column here. So what I'm gonna do is I'll take some I'm gonna take some string function here. So I'll go with a left string. Then maybe I need first 5 numbers of customer number into this. Let's click on OK, then activate. It's completed successfully. Now let's run the data plan, visualize plan again. Oops. Okay, let's see the data preview. Okay, let's open this. So it's saying attribute value is not a number. Here int. Okay, so we have used string function, right? So the data type should be nvarchar here, or varchar. So what I'll do is I'll just put nvarchar, then click on OK. Now activate. So it's activated. Now we should get the data. See, now we have got the data for this. So now let's run the visualization plan here. Execute. Let's get into column search, and then column search here. See, now you have got JE calculate. Along with join engine, you have also got JE calculate. One more component additional here, which means whenever you create any calculations, either at analytic view level or at attribute view level, by default the calculation engine will be called. That is the reason one of the best practice when you are doing modeling in HANA is always try to avoid the data transfer between different engines. So now unnecessarily you are trying to call the calculation view engine just to access your attribute view. So to perform that calculation, the data has to move from join engine to calculation engine, because you are trying to do one calculation at attribute view level. That's where one of the best practice when you are doing HANA modeling is always try to avoid creating calculated columns at attribute view level. Instead of that, create calculated columns in calculation engine, calculation view. Why? Because most of the times in real-time scenarios, you won't be exposing your attribute views to reporting objects. You will be exposing either analytic view or calculation views. So always try to do those calculations at higher level instead of doing at lower level. Again, it depends on the use case that you are building, but this is one of the best practice, and this is how you can visualize what are the engines has been called when you are trying to view the data from any modeling object. So this is the information about different engines we have in HANA and how those engines will be called for each modeling object. So the next topic we have here is row storage structure and column storage structure. So row storage versus column storage. So I mean, in my initial sessions when I was explaining about HANA introduction, I explained how column storage is useful and how it brings the compression ratio to your database, and then how it is going to be faster enough when you are trying to read the data from tables. Then why do we need a row storage structure in HANA again? Because if you create a new table in HANA, you go to your tables, right click, and then say new table. In the table type, you have row store and column store format. So why do I need a row store again in HANA? So let's discuss in detail about what is row storage and what is column storage. So we have seen how the data stores for row storage as well as columnar storage. Then what is the advantage that row storage has? Because otherwise people would have not used row storage for so many years. The major advantage with row storage is when you are trying to insert the data, that is going to be very fast. Why? Because entire record is going to be one tuple. So let's see the difference again. Maybe I can quickly bring the note we have discussed in HANA introduction part. See, so the row storage stores data like this: one record, one tuple. However, the column storage stores one entire column details as one tuple. Now let's say I want to insert another record into this table. Okay, so where you just say insert row below. So I want to insert another sales order into this. Quantity 80, then price $1000. Now, how this is going to be inserted at a database level? It just adds to this. That's it. Let me. Okay, so it will just add to the at the end of that data set. So it will be very easy. It doesn't need to do any logical operations to add this particular record to the existing data set. When it comes to columnar storage, so it has to pick this value and tries to add in between these two, and then it has to take the second one, tries to add in between these two, and it has to check whether this is a duplicate value or not. If it is a duplicate value, it should not store again. It has to maintain the internal indexes, and same thing it has to do for all the columns. Then think about 100, 150 columns in a table where you are inserting 500k records as a daily delta load. So how much time it is going to take? So that is one of the major drawback with columnar storage structure and one of the major advantage with row storage structure. So the insert operation will happen very fast with row storage structure, and we have seen how that happens. Whereas the select operation happens very fast with columnar storage. Why? Because let's take a simple example, simple query where I'm trying to write, refer the same table, or maybe I think it's better to copy this to our new Word document. Okay, so I'm trying to refer the same thing. Select sum of quantity from table A where product number equal to P2. Okay, so now let's say my table size is 50 million and distinct products 100k. Okay, so I have a table with 50 million records and the distinct product numbers I have is 100k. So now I'm trying to write a query which is select sum of quantity from table A where product number equal to P2. So product number P2, I want the sum of the quantity I have sold. Now let's say you have row storage structure. Let's say you have row storage structure now. So in the row storage structure, irrespective of P2, it has to read all 50 million records and identify how many records are having product number P2, then do the summation of respective quantities. When it comes to columnar storage, it straight away goes to your product column, and then the product column has only 100k distinct values. So in the row storage format, in the row storage structure, how many reads it has to do? It has to do 50 million reads. Whereas in the columnar storage, it will only do 100k reads. Because it knows that we are searching on product number column and the product number column has only 100k unique records. So it will search those 100k records, 100k unique product numbers, and search for the product number P2, then get the sum of quantity. So here itself you see the difference between the number of scans or the number of reads system has to do on the same table with the different storage structures. So it was 50 million for row storage. However, it is just 100k for columnar storage. That's the major difference you get when you try to read or when you try to scan the table. So the advantage with row storage is it can insert very quickly. The advantage with columnar storage is it can scan or it can read very quickly from huge tables as well. So being that in mind, now we have gone with columnar storage structure in HANA. So how you are going to overcome the insert disadvantage for columnar storage tables? So that is where SAP has introduced a concept in HANA. For any column table you create in HANA, you are going to have two storage components. One is main memory and other one is delta memory. So main memory always column store format, and the delta memory is always row storage format. So where I can see this main memory and delta memory. So you cannot see those things physically in the system, but if you go to table properties, let's open any table here. Let's say shop facts. So if I open the DDL, data definition of this table, if we go to a runtime information, this is where I can see the main memory and delta memory components of this table. So even though this is a column store table, which is column table, I've got main storage and delta storage, which is nothing but memory. So main storage and delta storage. So what is the difference between these two? Whenever you try to insert records into this table, all those records will be inserted into your delta storage. Okay, so when we say delta storage, it's a row structure, row storage. So which means it will have all the properties of proper row storage table structure. So what it means is when you insert, the records will get insert very quickly into the table. Now how this will be moved from your row storage, delta storage to main storage, because main storage is columnar storage and it will give you a very quick response when you're trying to read the data or when you're trying to scan the data from the table. So the data will be moved from delta storage to main storage with the help of, that will be taken care by system automatically in the backend, and that is called commits. So the operation of moving data from delta storage to main storage is called commit or delta merge. So this delta merge will be taken care by system in the backend. So we no need to do anything manually for that. So whenever you insert or whenever you load data into a table in HANA, which is of column store type, the data will be loaded into delta storage. And once the data is loaded into delta storage, which is row storage structure format, the data will get insert very quickly, and within next 5 minutes, or you are going to have the timestamp configured at the system level, within 5 minutes or 10 minutes based on the configuration, the data will be moved from delta storage to main storage, which is your columnar storage. So when you run query on that, the data will be read from a main memory, which is columnar storage. So you are going to have that fast response as well as the compression compression you get with columnar storage structure. So that is how in HANA, even though the table structures are columnar store, the inserts challenge has been overcome with the help of delta storage and main storage concepts. So now let's see what are the advantages and disadvantages of row storage and columnar storage. So if you see column store thing, calculations are typically executed on individual or small number of columns. That's one of the example I have given here. So even though you have 50 million records in this table, no one will be looking at what is the revenue I have got for sales order 41s or sales order 312, because there is no point of looking at revenue generated by one sales order. That doesn't give you any meaningful analytics. So you will be looking at the revenue generated by customers, or the revenue generated by different products, or the revenue generated by revenue generated in 2014, which means you are trying to aggregate the data. You are not looking at detailed, or you are not looking at operational level analytics. So you will be aggregating a data, and whatever the columns you are going to use to do the analytics, those columns will have very less number of distinct records, distinct values when compared to your most granular information like sales orders. So whenever you are trying to do analytics on columns which are having a less distinct values, then your columnar storage is very effective. So that's what it says. The table is searched based on the values of a few columns, and the table has a large number of columns. So if the table has large number of columns and you are trying to do analytics on only few columns, then your columnar storage is very effective. These are all when to use points, when you have to go for columnar store, or when you have to go for row storage structures. And then if the table has large number of rows and columnar operations are required, aggregates or table scanning, same thing I have explained. High compression rates will be achieved with the help of columnar storage structure. Then row store. So row store tables will be useful when you are not going to have any duplicates in the data, like system statistics information. So mostly you won't get any duplicates in the statistics information or statistics of your system information. In such cases, you can go for row store structures. So the application needs to process only one single record at one time. It's like same thing happens, like if you want a specific record to be displayed in the output, in such cases you can go for a row storage structure. The application typically needs to access the complete record. So when you have 200 columns in a table, and if you are trying to access 200 columns in the output, then it's always better to go with a row structure instead of columnar structure, because with this structure, so this is just 5 columns. When you have 200 columns, and if you want to display one record with 200 columns, it can simply bring that entire record from that particular memory point. But when it comes to columnar structure, it has to pick one value from here, and then go here, pick one value from here, one value from here. It has to do 200 tuples scan and then pick that particular record, which is going to be very expensive. So in that case, you can go for row structure format. And if you don't need any aggregations on the tables, then we can go for row store format. Then the table has small number of rows, for example configuration tables or statistics tables. In such cases also we can go for row store format. So this is about the row store versus columnar storage structure, and how that has been overcome in HANA tables. So to give the summary about what we have discussed in this session, in this tutorial, we have seen the high level architecture of HANA database, what are the different server components we have in that, and we have also seen in detail structure of index server and how each query will be processed in index server with the different components in place. And we have seen what are the different HANA engines that we have to process the executions on modeling objects we have created in HANA, like attribute views, analytic views, and calculation views. And we have also seen visualization plan, which tells you what type of engine has been called to execute that particular modeling object. And in the end, we have also seen what is the difference between row store structure and columnar store structure, and how that has been overcome in HANA with the help of delta storage and main storage. In the next session, I'll explain about persistence layer and what is the importance of backup and how to do recovery in HANA system. Thank you for watching. Have a good day and happy learning.